Aloha, Richard Halverson here, and this is its128, and I'm going to have my camera off because otherwise the uh, Zoom doesn't work very well. It's a slow computer, so you have to put up with my picture there. Let's see. Let me share my screen. I'm going to do enough screen number 1. Oops, wrong button. Screen number 1. Okay. And I'm going to put this over. You can't see that, I know. All right. So we are, this is February 13th. I guess we're like around here, chapter 5. So we're going to start chapter 5. And I'm going to do the challenge activities in 1 through 7. Because presumably, if we go to resources and go to playlist here, you can see that John Johnson, who hopes he can teach this class again one day, probably will be able to, did all these great videos here for these sections. And so presumably you'll watch those, and I'm going to do the challenge activities. All right, so and maybe I will be able to do this in a way where I can interleave them like I did a couple videos ago. All right, so in this case, in chapter today, we're gonna do the challenge activities in these 5 sections, and I'm going to assume that you've looked at the at this chapter already, and you know what loops are. Loops are, let's see, we've covered conditional expressions where you will execute a body, you'll execute a chunk of code if a particular condition is true. Otherwise, you skip over the chunk of code. Okay, that's the way an if statement works. Loops are just like a if statement, except for the expression, the if expression, which in this case it's called a while expression. As long as the while expression is true, then execute the loop body. Okay, so that means that the body, the chunk of code, can be executed some number of times, more than once. It could maybe execute a bunch of times. And as long as, and then when it's done executing, it goes back up and it checks that expression again, evaluates it. If it's true, it executes the chunk of code again. Of course, that means that there's got to be something in the body. There's got to be something somewhere that would make it where sooner or later this expression will evaluate to false, and then the loop will stop and it'll continue on down, just like an if statement works, where an if statement, if the condition is false, you skip over the block. All right, so and so you should go through these and see these examples. In this case, you can see where the condition for continuing to loop is that this user char variable is equal to y. If it's equal to y, then this chunk of code will execute, and it'll go back and evaluate it again. There's got to be something in here that will make this not equal y, and that would be here. You notice this last line here, we're reading in a new variable, or we're reading in a new value for this. And so presumably, as long as we input a y, then this chunk of code will execute. But once we input something that's not a y, then when this gets evaluated, it'll be false, and it'll skip over this chunk of code and then continue on down here. Okay, so that's a while loop. Let's do some challenge activities here. All right, so enter the output of the while loop. Let's start this up. And so we start out where g is equal to 0, and then while g is less than or equal to 2, then print g. Okay, so we come in, g is equal to 0. Is g less than or equal to 2? Yes, it is. So let's execute this chunk of code, and we print the g, which is going to be 0. And then we increment g by 1, So now G is equal to 1. Come back around, test this condition. Condition is true. So then we print G, which is 1, plus an enter. And then we increment G by 1. So now G is equal to 2. Come back around here, evaluate this. This is true. So it prints G again to execute. Then we execute this. Now G is equal to 3. We come back up here, evaluate this. It's false. G is not less than or equal to 2. It's greater than 2. So this condition is false, and we're done. So this is what the output should look like, and it is. All right, so let's see what this one is. This is the same thing, except for each time we're adding 3 to G instead of adding just 1 to G. So the first time it'll print the G, add 3 to it. Is 3 less than or equal to 5? Yes, it is. So it prints the 3. And we add 3, and now G is equal to 6. Execute this, and then it's false. So it's gonna be printing 0 and 3, but it won't print 6 because 6 is not less than or equal to 5. All right, so that's 2. You can do that one, whatever one yours is. Let's do this one. Okay, here we're going the other way. We are decrementing G by 1. We're starting out with G is equal to 0. Now, while G is greater than or equal to -1, a 0 is greater than or equal to -1, so it's true. So now we print the 0. And we decrement it by 1. So now G is equal to -1. Come back here. Is G greater than or equal to -1? Yes, it is. It's equal to -1. So we're going to print the -1 right here. We're going to print the -1. And then we're going to subtract 1 from G. And now G is equal to -2. Come back up here. Is G greater than or equal to -1? No, it's less than -1. In fact, it's -2. So we're done. So this is false. So we do not execute this chunk of code and we go on. So now we're done. So is this correct? Yes, it is. All right, what's this one? Same thing, except for we're decrementing G by 2 each time. And we're going to print it as long as G is greater than or equal to 6, is greater than or equal to -6. So when it's 0, it'll print. When it's 2, it'll print. When it's 0, it'll print. When it's -2, it'll print. When it's -4, it'll print. When it's -6, it'll print. But then after it prints the -6, it's gonna decrement it by 2, and then it'll be equal to -8, and it'll come back here, and this will be false, and so this won't work. So then we're done. And so you can check that yourself. Let's do the last one here. Okay, we start out with G equal to 4. Is G less than or equal to 5? Yes, it is. So we print 4. Then we add 1 to G, and now G is equal to 5. Is 5 less than or equal to 5? Yes, it is. It's equal to 5. So we print the 5. And then we add 1 to it, and G is now equal to 6. And so is 6 less than or equal to 5? No, it's not. So we don't print the 6, and now we're done. Is this right? Yeah, it is. Okay, very good. All right, let's do this one. While loops. A while loop reads values from input, writes an expression. Oh, no, we are supposed to write an expression that executes the while loop until the value E is read. The value E. Until a letter E is input. Okay, so we're going to read an input, and we're going to loop until value E is read. So when value E is read, it's going to stop looping. Okay, it's going to loop until the value E is read. So right here, I'm going to put, well, while the value E is not read, not E, no, while the value read, which is user in, while it is not equal to E, I guess that would be this, that's equal, not equal. While it is not equal to E, then we do the loop. Then it prints out this, prints out whatever they entered, reads it again, comes back around, and sees if the person entered in an E or not. As long as the person does not enter in an E, then this chunk of code is executed. It keeps on executing until the user finally types in an E, and then this is false, which means this chunk of code is skipped over and it goes down to the next line of code, which would be printing exit. So I think this is the answer to their, I think this is the answer, and it is. All right, let's see what this one is. Value, it's read from input. Write a while loop that reads values from input and casts the values into integers. This is a term. It changes them into integers, maps them into integers, until the integer 10 is read. Okay, well, so this will always read in a bunch of characters. So if you type in, 25, that's 2 characters. If you type in 625, that's 3 characters. Okay, so this reads in some characters, and then this int function, which surrounds the input, once it's read in, then the input function is applied to it. That's this casting. Okay, so it's casting it into integers. All right, so we're supposed to put in a while loop that reads. Okay, here we read it. Write a while loop that reads values from input and then casts values into integers until 10 is read. Okay, so all right, we've already read in the first one. So now we just do the while. While user number is while it's not equal to 10. While it's not equal to 10, then update in each iteration, I'm going to update int sum with the sum of int sum and user number. So in other words, it's going to be, I'm going to add user number to this value, which we're summing up all the numbers that are read in. So while user number is not equal to 10, int sum equals int sum plus user number. Okay. And of course, I can do the shortcut, which is just put a plus sign. Since this and this are the same, then I can get rid of this and make this plus equals just that. That's the shortcut way of writing it. Okay. Int sum equals int sum plus user number. It doesn't matter. Okay, so we increment it and then we read the next integer from input. So that's just going to be doing this again. I'm just going to copy this here and I'm going to put that thing right here. All right, so so it's going to keep on reading user numbers, casting them into integers, and this is an integer, and then it's going to come back around, check to see if it's 10. It's not equal to 10. It's going to sum it up. It's going to keep on doing that until it's done, until the user types in a 10. At that time, it's going to print out what the sum was. Let's check this. All right, What's next? And this one, we're going to make a loop, make a while loop that iterates until the user in is negative. So it's going to loop until this is negative. It iterates until that happens. Okay, so while user in, while user in, it's going to loop until it's negative. So while it's not negative, which means while it is, see, negative means less than 0. So 0 is not negative. So while it is greater than or equal to 0, then it's going to be not negative. While that's the case, what are we going to do in each iteration? Well, update the final sum as follows. Oh, okay. So we got a fancy. We have a conditional here on updating final sum. So if user in is not divisible by 3, okay. If user in is not divisible by 3, so how do I test if it's not divisible by 3? If what's going on? If user in mod 3, if user in mod 3 is equal to 0, then it is divisible by 3, because it's going to be 3 divided by 3 is 6, 9 times. Okay, if this is true, then it is divisible by 3. And so to do the opposite of that, I'm going to do this. I'm going to make this a bang. So if user in mod 3 is not equal to 0, that means it's equal to 1 or to 2. If it's not divisible by 3, then output hit and increment final num. All right. If that's the case, then I'm going to print hit and increment final num. Now, in the old days, we would have to say how much we're incrementing. It's not assumed that it's just 1. And in fact, in the old days, if I were to read this, and by old days, I mean maybe the 1980s or something, it's 40 years ago, I would say they must mean increment final num by 3. But I know it's not the old days, it's today's days, and we mean increment by 1. So that's why I just put by 1 there. All right, so that's incrementing final num by 1. Otherwise, output miss and do not update final 1. Okay, so that means that we're going to do an elif. We're doing, oh no, there's an else to the if. So we just put that in here at the same indentation level. Otherwise, print miss and don't update final num. Okay, so oh wait, we have to read in user in again. When do we read in user in? Oh, then read a value from input. Okay, there we go. We got to read user in, and that would be at the same indentation level as the if. So I'm going to go, oops, user in equals int input. There we go. So that's the same as that. Okay, so this is the chunk of code that executes if the user in is greater than or equal to 0. And this does something, looks and sees if it's divisible by 3. If it is, it says hit. If it's not, it says miss. And then it does this thing, which is read in another user in for this conditional test. You know, the one thing about a while loop is you got to make sure that there's something inside that's going to cause this thing to, or there's something is gonna happen which causes this thing to be false eventually. Otherwise, you end up in what's called an infinite loop. You've all heard of infinite loops. All right, so let's see what this is. This is correct. Ah, very good. Okay, so that's the end of the challenge exercise in 5.1.3. So I'm gonna stop this recording and restart it. Okay, thanks for watching.